generative AI. And so Nick's a colleague of mine who recently gave a presentation internally about sort of the more advanced topics, and I thought it'd be great for this audience. So similar to what we see at a industry conference, he's going to present what his team is working on, but it's just one of many ideas. So we're very excited to hear from you all what your company may be doing similar or different when he's done with that. So Nick, I'll let you take it away, and then we'll have the panelists do introductions when you're done, if that's okay.
Awesome, perfect. Yeah, I'm Nick Bordelot. I'm a colleague of Scott. I'm from Quebec, Canada. I've been working here at Coveo in the search industry for 17 years now. I was a developer in the past, moved to product management a couple of years ago, and I'm now VP product at Coveo. I manage our search platform and our I would say website and workplace use cases. Glad to meet you all. As Scott said, today's presentation is something that I built for kind of education internally at Coveo, to educate about what we're building, but also where the industry is going and what is a few core concepts. So happy to present that to this group, and also happy to get feedback on what we are building. We are actively building those things, and the industry is also shifting and moving. So if you have good feedback or bad feedback or whatever, basically now is a good time to gather that feedback, because we can still change a few things as we are developing. That's what I had for an intro, Scott.
Awesome, thank you, Nick. And are you able to share your screen okay?
Yes, wasn't sure if you wanted me to go right ahead or if
go ahead. Thank you.
Okay. Should I get started, or you said that there were some panelists that should go first?
We'll hold that till when you're done, if that's okay. And one thing I forgot to mention to everybody is, if this doesn't make sense, the previous meeting that we had, sort of the 101 level course, if you will, is available on my website, scottbedot.com. So you could always go back and review that later, and then we'll also post this recording there as well, for everybody's benefit. So take it away, Nick.
Great, thank you. Okay, so today's agenda, I want to talk briefly about what we're seeing as behavior changing in the world of search related to Gen AI. I want to cover a few core concepts, because there's a few concepts that need to be understood before we can talk about how do we apply those concepts of Gen AI and vectors and embeddings to search. And after that, just a few additional resources, things that I've liked and that I think you might also like. So kind of a link repository at the end, just to share some more knowledge. So again, right in, behaviors are changing. We are seeing more and more long form question, natural language question. When we work with customers, we have the luxury of being able to look at their analytics, and we see that question. There's still some few keywords question. People are typing a few keywords, but there's more and more long form question. It's not the majority of questions that are yet long form question in natural language, but there's more and more of that. Obviously, people are typing more long form question because they're starting to get better answer when they type long form question. If you were not to get the right information for those long form, we're all lazy. We would keep going with smaller and just a few keywords in there. But because the word is evolving with LLM, but also with just plain old search engine, people are typing more and more of these questions. So what do we do with these questions? There's search, good old search. So in a search box, you type in the keywords or long form question, you get predictive query suggestion, you get basically help to help you formulate that question properly. We can help you find out the right keywords or find out how to formulate that question to get good results. And then you get a good old list of search results. That's really helpful if you're looking to discover information. If you're doing research, You want to be able to get lots of information. You want to be able to slice and dice this information to dig deeper. Not a lot of people go beyond the first page of results, but a lot of people use navigation and use filtering in multiple ways in there to change the list of results to be able to still in the same first 10, but now see per source or see per category or see per different type of information. But still, search is we think is there to stay, and people still need to have access to search. But as I was saying before, we're seeing more and more long-form question, people typing a long form. Typing a long-form question in a search box is natural. Typing a long-form question in a chat bot is also natural. So what do we do with both? How do we combine both? When people type in a long-form question, they expect to have an answer back from the engine. I'm personally not a fan of chatbot. I prefer to go with LLMs and stuff like that to get a long form answer. So as I was saying, we think that search is there to stay. We see that question answering is taking more and more space. The problem with having two systems like that is that you need to maintain two systems. So what we are doing and what we're seeing also in the field is that there's more and more convergence of both systems. Basically taking the best of both worlds, having a single source of information being made available for both systems to be able to provide yes results, but also provide answers when you type in the search box. That's a bit of an intro. What I want to do today, I want to explain to you all the things that are in that slide here about how do they work. How can, in the end, can we get a list of documents and provide an answer formulated exactly to the question that was typed in the search box? You'll see that slide multiple times today. As I mentioned, the idea is to explain pretty much everything that you see in there. It's probably confusing for now, but we'll dig step by step. So core concepts. In the end, that's what we want to offer. We want to offer, I mean, when I say we, I don't mean us at Coveo, I mean globally, what people are asking for, they're asking for generated answers. They want to have, when you type a question, they want to have something that is generated a precisely answering their question. Think about it, opening results and finding the information is kind of an intermediary step. If someone could be looking at all the results, tell me which ones are good, extract the information and provide the answer that is exactly tailored to what I've typed in the search box, well, result list is pretty much not useful. I would much prefer to get someone to summarize the information for me and make sure that this answers my question. So that's what we're trying to do in the industry. We're trying to basically tailor everything under the hood so that in the end we can provide exactly the answer that you were looking for at that moment. To support that, this is the infrastructure. And the first thing I want to chat about is about how do we interact with an LLM and what is retrieval augmented generation. So when you chat with an LLM, if you chat purely with, let's say, ChatGPT, or there's other, but ChatGPT is the most known, you type in a question, or you can type in pretty much anything, and then the LLM, the ChatGPT will provide you an answer. What it does under the hood. Actually, you've probably seen the session, last session on that group was basically explaining exactly what an LLM does. It's a big statistical model, and based on on what you provide as a starting point, the question, the first part, it'll complete it. If I'm asking it information about something that is well known and widely known, chances are that the answer are going to be true, but they might also be false. LLMs have a faculty to hallucinate. If I ask an LLM what is the birthday of Donald Trump, let's say, chances are that it'll be true. It'll get the right information because that information is public. If I ask the same question about my personal birthday, that information is not public. But the LLM won't say that he doesn't know. He'll say that my birthday is August 8th of 2023 because whatever reason he's trying to fill the void. And that's not something that is reliable in an enterprise environment. You cannot have something that hallucinate answers and provide false information to your employee or your customers. So to go aside of that problem, there is what is called retrieval augmented generation. That's when you basically add the step of asking for information, basically querying a search engine in between the question and the answer. So LLM gets a question, takes that question, reformulates it, sends some queries to a search engine then return results, and then the results are now mashed up as an answer provided back to the user. We'll talk way more about that. That's just to intro the concept. Actually, in reality, it's a bit different. The LLM is not really the middleman who gets the question. The LLM is responsible of providing the answer, but there's someone that is building an application that is taking the question, sending it to the index directly, and then the paragraph or the information, the snippets, are then sent to an LLM that send the answer back to the user. Just wanted to make that correction right away before going further. What are the benefits of RAGs? Benefit of retrieval augmented generation, grounding. Because you are providing facts and because you're providing information to an LLM, you're basically telling them what's the set of facts, what's the information that we all know that you should be based on to provide an answer. What are you grounding your information, your response on? You're grounding your response on a set of facts that you're providing to the LLM. It's reduced greatly hallucination once more because we're providing the information to the LLM to be able to answer a question. It would greatly reduce hallucination. For now, I would say that it cannot be removed completely because LLMs have the faculty to fill the void. And even if we say to them in the prompt that we don't want them to hallucinate or answer you don't know if you don't know, there's some time where those models typically will provide an invalid answer, and that's part of what those models are. Let's assume that in the future they're going to improve and they're going to have better way to provide hallucination. Citations, because you're providing the information to the LLM to provide an answer based on, you can also provide a source of information to your users. If you want to be able to validate the source of information, it can be done. Basically, users see the answer, it's coming back, and then you can see, so that part of the answer is coming from that snippet, that part is coming from that document, and then people can go from there. They can simply validate the information, or they can also expand and learn more from these sources. And the last one, consistency, because we're grounding because we're grounding the LLM, the impact of time and the impact of variation of the LLM are greatly reduced. LLM are kept up to date, not every day, but LLM change, version change. The LLM itself is trained on a set of data and the training model is going to be the same for a long time. You've all heard that ChatGPT was trained on the latest version of the internet, was dated to, I think it was something like 2021, something like that. But the model itself is going to be evolving. There's 3.5, 4.0, and then the way those models are going to be answering the same question is different. By providing a set of facts, you can also provide consistency to the user. So if a user types in the same question day after day, they should be getting the same answers day after day. Or if different users type in the same question, they should be getting similar answers day after day. Who else does RAG? I'm sure you know the answer to this one. We've all used them, Bing and BART, and there's many others, but those are the biggest one. There's a few drawbacks though for the enterprise. Well, those platforms are limited to public knowledge. If your knowledge is public, chances are that you're going to get pretty great answer on questions specific to your knowledge from these platforms. But if you have let's say a private section on your website, or content is gated for authenticated audience and stuff like that, then you wouldn't get answer from those systems. It's also available only on the web, meaning that if you want to host those systems on your own premises, on your own sites or stuff like that, it'll be hard. Actually, it's simply impossible for now to host them on your own site. And then you have not so much control over the relevance, over the content source, or not control over pretty much anything else. So that's why enterprises are looking to build their own RAG and use systems to do retrieval augmented generation and offer answers to their users. Quickly, when should you use LLM versus RAG, ChatGPT or Bing or Bard or others? Well, LLMs are really good at reformulating text, changing tone, helper for linguistic, analyzing text and stuff like that. Basically, if you want to summarize a large piece of text, you send that to LLM, it's going to be summarizing it to you. If you have a sensitive email that you need to send to someone, if you want to make sure that it's the tone is okay, or if you were angry when you were writing something, you want to change the tone, send that to LLM. LLMs are really good at that. They are big, large language model. If you don't rely on facts when you use them, they can do magic basically. When should you use RAG? You should use RAG if you're trying to find information, if you want to discover information, if you're asking questions, if you want to summarize knowledge. That's when you should use RAG. So one is a linguistic tool. The other one is really more of a search engine, which we're used to do with search engine, but now in a summarized way, in a more concise way to get access to information. Digging a bit into a few more concepts before we go further. So vectors, embedding, vector database, semantic search, keyword search, lexical search. What are all these things? All these things are required to be able to do retrieval augmented generation. So let's dig in. First, vectors and embeddings. When you have an AI model, whatever is the model, one function of those models is to take an object and to create a vector at the end out of it. A vector is just a numerical representation of an object. Computers like numbers, they're able to do magic with numbers. If you provide an object, a complex object to a computer, it's really hard for them to do anything with that. But if you transfer it, if you characterize it with an AI model, as a vector, it's much easier for a computer to use those objects. What about embeddings? Embeddings are basically a variation of a vector. We use embedding when we talk about large language model. So if you use words, sentences, or actually paragraph, whatever text format that you want to send to a large language model, they're going to send back vectors. Those vectors are called embeddings. They're the exact same thing. They're basically a series of numbers that represent the group of words that you send to that model. What do those number represent? Sorry, they basically represent if you want to see it graphically, they represent a position in a grid. In this case, I only have a two-dimension grid, X and Y. Reality is that LLM models position words and create vectors, but in multi-dimension. There's vector model with as low as something like 300, 400 dimensions, but there's other which are really, really big, which contain something like 4 or 5K dimensions. There's different model. The better ones typically are bigger, but they are also more expensive to operate. So when you put these vector into that grid here, you can see that apple and oranges are actually closer than a dog. Both are fruits, so they're close one to another. They have different colors, so they're not the same fruit, so they're not at the exact same place. And a dog is different, is farther because it's not a fruit. All of these are organic matter, so they should be closer than, let's say, a plane that could be at the exact opposite in that same chart. So by having a graphical representation, it's easier for us to understand. And by having numerical position of these things, it allows us to do basically semantic search. Things that are closer to another in that vector space tend to be related by some sort of relation based on the English language. So because of that, we can now do search. If I were to type in elephant in there, elephant is probably closer to a dog than it is to an orange and an apple. Both are mammals, so they're closer to another. And then if you would have, let's say, a giraffe and a lion, chances are that they would be closer to elephants because they're from the same region of the world, but in another other dimension, maybe they're extremely far from another because they're not the same color or stuff like that. So it's kind of hard to visually represent that model. Our brain is good in 3D, but in 4KD, it's actually harder to represent all those words. So semantic search. So you now know how we can do semantic search. Basically, we take the few words that are typed in the search box. We transfer them into an embedding. We then talk with a vector database. Vector database is basically a structure that store all of those embeddings, and then we can do proximity search with them. So if I were to search in for programming, I get a numerical representation. I ask the vector database, please send me everything that is as close as possible to programming. I would get results on the topics of programming, software development, code, and there's probably also other concepts that are closer one to another. There's obviously pros and cons. There's always pros and cons on anything, but pros, synonym recognition. You don't need to type in synonym recognition. The semantic part of the language model, is able to do that part for you. So if you type in some keywords, you're going to get some synonyms that are returning back because of the proximity. It also tolerates ambiguity. If you don't know the exact keyword that you should be using to find information about a specific topic, semantic search is going to be able to extrapolate for you, and you don't need to know exactly what's the exact keyword that you want to search to be able to find the information. Contextual understanding. In this case, I only have one keyword in the search box here, but the more keyword you have, the relationship between those keywords are all part of the same vector. And now a sentence vector or a few keyword vector provide more context about what am I sending. If I'm only sending a few keywords for semantic search, all those keywords are taken individually. But if I type more keywords one to another, a bank account is not just a bank and an account. It's a bank account, so we know that it's an account in a bank. It's not just a bank that could be a food bank, and an account that could be an account for an accountant or whatever. There's the meaning of the word one another are actually represented in the embeddings and make sense together. There's high recall. If you have a small set of information and if you want to make sure that you're getting a lot of results coming back for your query, using semantic search is really good because you're going to get large amount of documents coming back or information coming back. So recall is basically the number of results coming back for a specific query. On a con side, it's really expensive. It's resource intensive, meaning that you need to have all that information in RAM somewhere to be able to do the maths to extract to run semantic search basically. And then accuracy in complex scenario. If you're trying to do semantic search in a precise field of activity, language model are typically not that good in precise in complex scenario. So that means that semantic won't be as good. Let's say in a highly precise, regulated finance environment versus the good old common knowledge. So in complex scenario, it's a bit harder to get good results from semantic search. The other side of thing is keyword or lexical search. So same thing here. If I type in programming, there's going to be a few steps that are going to be processing the query. I chose only to talk about stemming today. But there's did you mean, there's query correction, there's automatic correction, multiple things. But stemming is the one that expand really the query to be able to go wider. So that's when I picked this one. Stemming is really about going and taking the stem, the root of a word. So in the case of programming, the stem of that word is program. If I search in my lexical index, I'm going to get results about actually all the same topic, but that start with that same root. So programming, program, programs, programmer, which is great. It's really precise, but it's less wide. The recall is smaller than what I had before. Pros and cons: simple to deploy, well-known in infrastructure and technology. Performance are really good, meaning it's also cheap, easy on resource, cheap. Homogeneous data set accuracy. If you have a large amount of information on the same topic, keyword and lexical search can be really good at pinpointing exactly what you're looking for, even if you have multiple pieces of information on the same topic, because there's all the algorithms that are trying to find proximity in words and stuff like that. So even if the data set is homogeneous, you're able to do something good with lexical and keyword search. Cons: Limited recall, meaning that the recall is only going to be on the specific exact root of the word that you typed. So you're not going to be able to catch it with a wider net. Really reliant on user knowledge. If you don't know the keywords, you won't be able to find the content. So it's harder to do discovery of concept with keyword and lexical, and no context understanding. The exact opposite of semantic. If I'm typing a few keywords, there's no understanding of those keywords, the relationship between them, aside that they should be close to one another in the information I'm retrieving. So that's the other side of the things. As you probably seen, the pros of one are the cons of the other. So best of both worlds is really to be able to combine both. So to perform a keyword, a lexical query on one side, to an index and get results, and at the same time performing semantic search and getting results back. And then at the index level, you can merge both results set and decide if you want to have more lexical, more semantic, and then return a result set, a single result set to your user based on that query. If we glue all of this together, so we've seen LLM or ChatGPT, we've seen vector database, embedding extraction. So now, how do we glue all of that to a structure of good old search, basically? Let's look at the first at the bottom part. So connectors, extraction, and of embeddings. So I won't talk much about connectors, but basically connectors are able to go and look at various sources of content and extract information from the source. What we get on the index side is a document, or basically a blob of text. That blob of text need to first be split into paragraphs to be able to index and create embeddings of those paragraphs. Splitting into paragraph is quite important. You want to be able to find to feed the LLM, with relevant paragraphs. So where do I split a document into relevant chunks of information? There's a whole science behind that, but basically splitting a document into paragraph, and it's not as simple as looking into spaces or break line. You need to be able to chunk it down, and once you've chunked down the information into relevant snippet, that need to be converted into embeddings. If we want to be able to do semantic search on that, you need to be able to convert that into an embedding, obviously. So after that, you have the textual representation to do lexical search. You have the embeddings to do semantic search, and then you have paragraphs that can be used to generate the answer when you talk with an LLM. Now let's look at the middle section, the index and the vector database. So these both pieces are actually blended together. There's multiple ways to do it. I'm talking about how we do it at Covil, but there's multiple ways to do it. We decided to blend the index and the vector database together into a single structure that provides us better control in multiple things. But basically, in the index, we used to have document. Now we have paragraph and embeddings, and we can perform semantic and lexical search at the same time. Why would you want to combine text and vector database into a single index? Well, we can do semantic and lexical search at the same time. It can provide really great performances. You have only one structure to manage versus having two different structures. And one thing that is important to understand is that there's multiple steps into ranking and to providing good results to a query, be lexical or be semantic search. And the first step of ranking is done at the index level. So if you have one single structure that contains a document, the text and the vector database, you can then perform a first set of ranking. You can prune document per security. You can prune document if they contain or not the keyword, and then you have full control to return a first result set that then can be further ranked by AI and by other technique. But at least at the index level, you can weight both documents, and you don't have duplicates that are coming from lexical and semantic and stuff like that. So there's companies out there who do only lexical, who do only semantic. There's others that just like us do both. we think that doing both is more powerful. So we've seen the bottom part. We know that secure connectors are creating the embeddings. They go into the database, into an index. Now we have a full structure that's able to do that is able to do hybrid search or combining lexical and semantic search. How do we get to return results and answers? That's the next section. So hybrid search, we've covered that briefly. If I were to abstract that into the next representation here, when I get something in a search box, how to add a bank account, first thing I do is I perform an hybrid search. That hybrid search is going to be returning results and paragraphs. The initial response is returned directly to the users, meaning that the results are returned to the user. So first thing you see in the search page is a list of results. The paragraphs are returned to the LLM. So we send those paragraphs to an LLM, and we basically ask an LLM, take that information and answer the question at the top. And then the second part of the response is basically streamed in the interface, and then you can see the answer appearing as the LLM generate the answer. When you talk with Bing or Bard or whatever, you see that they are feeding the answer as it's generated. That's how the LLM work. Once they receive a first set of keywords, and then they answer additional keywords, and then the additional keywords are also part of what they are using to finish the answer. So that's why it's important to stream the answer so that the end user can see it as live as possible, so that they get the information that they want before starting to click on results. How do we talk with an LLM? So you've seen the easy version before, and now it's a bit more discrete. So when you perform a query, it goes to the hybrid search. The paragraphs are generated. Now, before I'm talking with an LLM, I'm gonna go and look at the input of an LLM. LLM takes LLM will take basically a prompt. So you basically build a large blob of text that you send to the LLM. And what we do for generating relevance, retrieval augmented generation, let me take a pause. I'll just take a quick shot of water. Okay, I'm back. So when you talk with an LLM, you basically feed them a big blob of text. That's what we call the LLM input. So LLM input is made of multiple things. Let's look at what was a prompt. So if I type in a prompt of LLM, explain antibiotics, I also have to type in answer. I want them to complete that sentence. I want them to fill the void. They're going to output basically what are antibiotics. They're a type of medication used to treat bacterial infection, and then they fill the void. You can go and you can ask follow-up question. Basically, you add more information to the prompt. In this case here, I'm taking the answer from the previous, and then I'm asking explain the above in one sentence. I'm asking them to shorten text, basically to do a basic manipulation of text. And then he's going to provide the answer based on this time only in one sentences. You can create more complex prompts to talk with an LLM. When you do RAG, basically, that's typically what you're doing. So you answer the question based on the context below. So the question is at the bottom. What are OK3 original sourced from? Based on the context, I'm providing also context. I'm providing basically the information that I want to see in here. I want to see him use to provide an answer, and I'm also providing a few more instruction. Keep the answer as short and concise. Respond unsure if not, and things like that. So because I'm prompting the LLM with that, the answer is going to be basically at the end a mice. I've sent them information about how a drug was created. The question was where it was sourced. And then the answer was mice. It was actually taken from the context. He did not hallucinate. Probably if you ask that question to an LLM, just the question without the context, he's gonna tell you whatever he wants. If you're asking him to answer the question based on context, he's going to be much more precise and answer the question from a precise context. To do things like providing citation, you can add more things in the prompt. Now I have the same exact prompt, same exact context question, but now I am adding identify the part of the context that were used to generate the answer. In this case, I'm going to get the answer is mice, and the answer was found in the following extract, originally sourced from a mice, the molecule, blah, blah, blah. So the LLM is able to tell me what's the source of information, the answer, and then it's basically up to the application to render that information correctly into the view of the end user. So if I get back to here, basically, so the input that we're sending to the LLM is basically the prompt. So a pre-formatted prompt, basically a prompt template, basically. What do you want the LLM to do? You're providing the query context. What did the user ask? You're providing the paragraph or the snippets of information that were returned by the search engine, sending that to the LLM, and then the answer is going to be returning back from the engine, and then you can stream that information back to your users. And that's it. Basically, when you do that, you can take a question, be it a small question, a few keywords, or be it a long form question, and then you can return results. And if it makes sense, you can return answers. We're going to return answers if we see that the question is long enough. If you only have a few keywords that make sense to create an answer out of that, no, actually the answer won't be able to, the LM is not able to provide an answer only for a few keywords. If the search engine is returning only a few bits of information, we're able to know also that the LLM won't be able to provide an answer. So we're not asking for answer in that case. And in some cases, it's the LLM that also is telling us there's no information from me in what you provided, so I'm not going to provide an answer. So even if you have that infrastructure in place, it's important to put some safeguard not to always provide an answer, because as I said before, LLM like to fill the void. If you give them some room, they'll fill it, and they can provide any information. And you want to stay as factual as possible. You want to make sure that what you're providing out of a search engine is based on the knowledge that he received as an input, not based on what LLM can create. Additional resources. Basically, I initially, when I started this year to be curious about LLMs, I found that Cohere, I think it's a small Canadian company, they have a great LLM university. Basically, if you go there, they have lots of courses. They have the video and also the textual format. If you want to learn more about LLM, how do they work? It goes pretty deep, and you can learn a lot from them. Microsoft also has good articles on LLM and actually on RAG. The start point that I have here is actually they talk about how to do RAG and how to prompt in the engines and stuff like that. So that's a good starting point. There's a lot on Google, a lot on YouTube. There's a lot of things that are high level, but the more you know about the keywords, the more you know about the field, the easier it is to get good information from Google. I'm a big fan of learning on YouTube as I'm about to get to sleep. So YouTube, there's also great content in there. I haven't put any links, but all of that to say, be curious. LLMs I think they're there to stay. I think they're there to help us get easier access to information, and also provide us great tools to reformulate and basically change and work with text. So be curious, because I think that this technology is there to stay, and you should be knowledgeable about those things. And thank you. Basically, that's what I had for you today.
Awesome. Thank you, Nick. So at this point, I might ask Eric and Dr. Wu to introduce themselves, two resources who have volunteered to help sort of facilitate a panel discussion here. So Michael was on, our last call and did that presentation, and he and Eric can, help guide the conversation here. So would you guys mind introducing yourself really quick?
Yeah, I can jump in. So nice to meet everybody. My name is Eric Emmerman. I'm a director in our data practice at Perficient. I do a lot with generally where I focus is how do I get data from an organization out to the customer experience, the employee experience, the user interface in some way, shape, or form. So I do a lot with search, but I also do a lot with generative AI, APIs, all of those various areas as we help our customers kind of build detailed experiences. Pleasure to meet everybody.
Awesome. And Dr. Wu, are you still there?
Sorry, I wasn't realized I'm muted. Sorry.
That's okay.
Yeah. Sorry, I wasn't. What was the question again?
Oh, just a reintroduction for those who were not on our last call of yourself.
Oh, I'm Dr. Michael Wu. I'm the Chief AI Strategist at Pros. So I oversee a lot of this development of using generative AI in our product. So
Awesome. Thank you. So definitely open it up to questions and conversation. You know, as Nick mentioned, he's just presenting one solution that I happen to be, you know, obviously close to, but my passion with these meetings and this project has been to sort of go beyond the marketing hype, right? And talk about, you know, real practices that we're all seeing. So let's open it up and see what you all are doing at your companies, you know, whether you're building this type of technology internally or looking for third-party solutions. Did the content help you in conjunction with Dr. Wu's presentation, you know, better understand how this stuff actually works, et cetera. So I'll just open it up to anybody who wants to jump in. And please, not everybody at once.
maybe I'll go a little bit talk about kind of how we are using these generative AI in kind of a enterprise search kind of approach. I think, yeah, having the lexicon and kind of semantic search is really interesting. I mean, having that balance. So the way so basically, I think at Pros or in any other company, we always have the problem of having too many documents and they're not like well tagged or label or everything, you know, and sometimes it's hard to you know make sense of it when you just type in a long form question. Usually, you know, user questions about products tend to be very specific, right? So they ask about a specific bug, a specific, you know, when it, in certain instance, certain context when it happens, and so those are very specific things, right? So I think and coming up with a long list of kind of documents for those sometimes is not very helpful. And so what we did is, like, you know, exactly, we're using these retrieval augmented generation to get a generative AI, a ChatGPT, essentially to kind of summarize the result that's actually provided through search, right? Basically, and this, I mean, just to add a little context from what Nick has mentioned, right? Basically, this, you know, embedding and kind of index that, you know, give you, I mean, sometimes your document can be very long, right? Now, it's not every part of your documents that will answer the question, right? So I think by chunking it up into little pieces and kind of indexing them, right, you essentially, and then the vector database simply give you a way to kind of find the most relevant piece of information to give back to the, remember last time I talked about the, you know, your search engine is doing the heavy lifting, right? It's telling you that, you know, the answer is in these documents somewhere, but then you're giving to ChatGPT, and so ChatGPT can actually tell you, you know, this answer in a way that's kind of in using natural language, right? So like not, so this, to answer your question, you know, like this is how you use, and then they will give you a deep link to precisely that chunk of of paragraph, right? Or, I think everything to us is just document. I mean, the way we look at it, everything is just documents. So.
Hey, Scott.
Yeah, hey, Laura.
Hey. So I'm not sure really what my question is on this, but I want to describe a scenario and just see where it takes us. So I had an interesting observation with some of our data recently where we saw that a customer described a situation in a case, and the language that they used was pretty common, and they used some words that, I know that this is a scenario that you see all the time, where they described a situation where their system was down. So even just those words, system is down. If you think about the words themselves, they aren't very technical, and they probably don't match documentation that you've written in a very technical way. And so, we found that it's after, kind of deciphering and translating, if you will, that to something that's more technical, like tenants are offline. I'm just curious, like, is that in terms of linguistics and the natural language processing? And I mean, is that something that you see AI helping us with, just in terms of connecting customers, users, to the documentation that's written in a much more technical way, when their symptom that they're seeing and the way that they think about it is a more common language?
So there is a way to go about that, right? I mean, it's by having the system context as part of the kind of the search query, right? So I mean, I think that the user's experience, the system is down, but the system can be anything, right?
Right.
So, but the user is I mean, so I think some products are really clever now. They're basically, I don't know, I'm an Android user, so they will have like these system logs that are part of your kind of support kind of query when you ask for support, right? So you could tell them, black screen, not very useful information, but then you will know, like, which app are you using at that time, and so it will provide all the context simply from the fact that you are actually asking it at that time. So these are kind of auto kind of, I would say, infused or filled in context from the system, right? So I mean, so if he's able to do that, then that's fine. I mean, AI is not going to be able to, I would say, automatically make create those contexts for you. Those contexts have to be there. I think AI can help you interpret them and make sense of them.
And I think to add to that, that's one of the real benefits of retrieval augmented generation, that essentially you're using those traditional search techniques where you likely maybe have already done some work incorporating the context from your organization in, right? Maybe the system is down. Well, okay, what products does this customer own, right? I can immediately start filtering down my content to the products that they may care about or they may be accessing based on what they could be referring to as the system, right? So now my set of documents to recall against is a quarter, a half, a third, an eighth of what it was. I'm trying to narrow in on what the appropriate kind of answer is, right? The other piece that really ends up applying here is, if you do this with a pure LLM approach, the same information that the LLM knows is known to everyone, right? It's trained on a big set of data and it gives answers globally. With retrieval augmented generation, you can pre-filter access to information down to the appropriate context or security permissions or what have you automatically, so that the answer is being generated off of a smaller subset of documents, right? A slightly similar use case, kind of a little bit different, but we've done some work with some very large organizations on their intranet, right? And when you get to a certain scale, say 400, 500,000 employees globally, right? You start getting problems where a simple question around how do I get my pay stub, right? That's simple in a small organization. Here, go to this document. It says how to get your pay stub. At a really large organization where there's 17 different payment providers and across 23 different languages, and it depends on your department, your group, your language, your payment currency, and everything else, that becomes a really challenging problem, right? And so simply the idea that was just brought up of the context comes in to help further kind of refine that query in the back end, unbeknownst to the user, because I know who's asking, I know the information about the user, and I can refine down the set of information beforehand, essentially is doing the majority of the work and helping to get that recall set to the LLM so that it can then answer the question. And the user had to do nothing to kind of do that in the first place, just because we can intelligently, as system designers, make sure we're incorporating all that information. Does that make sense?
Yeah, thank you. I think so. I also just was thinking that there's a need, maybe, especially as people are getting more used to working with LLMs, is the prompts and some prompt guidance or prompt education to help them get more successful, with and get to the answers that they're really looking for.
I think in the case you described before about system down, tenant offline, I think that pure semantic is going to be helping a lot, because system is down, computer is off, tenant is off. All these things are related one to another. If the system you were using before is a bit more on the lexical keyword search, then you won't get any match, and then the way your user described their problem is on their own word, and they don't know your exact language. But by having the semantic layer on top of that, there's a link between tenant offline and system is down. There's a link somewhere in the language model. So by using semantic search, I think you would get much better. And then as Dr. Wu was saying, if you use the context of what your users are doing, if you had that also into the mix, then you're going to get much better information back.
Yep, exactly.
Hey, Eric,
right,
you mentioned a couple examples of what your team is doing with clients. Would you maybe elaborate on that a little bit? That's one of the reasons why I was excited to have you on the call, because you guys are involved in not only building maybe systems from scratch, but then maybe integrating things together and then turnkeying things. Maybe give the team here an overview of maybe what percentage people are falling into those different buckets, and maybe we can have others jump in with what their organization is doing and challenges or successes they're experiencing.
Yeah, of course. I'll get in that one second. I just want to give one thought on something Laurel mentioned around the prompts, the ability to understand prompts a little bit better. My personal view on this, not proven out with any data, just kind of what I'm imagining, intuiting based on what I've seen, is that we're with LLMs and ChatGPT like we were in the early days of the internet with Excite or AltaVista or those search engines. If you remember right, back in the day, you're using early Yahoo or what have you, they all had an advanced search feature kind of front and center, do your search or click advanced search, and we'll give you this whole guided wizard into how you search and say includes or doesn't include. Look at modern Google, look at any modern search experience and try to find the advanced search experience. It's really not there. And it's not fundamentally that, in many ways, these platforms, they have gotten smarter, right? But it's not fundamentally that advanced search experience is now completely just not useful anymore, right? It still can be useful to filter things down. It's that generally the populace who uses these platforms has gotten used to the UI conventions, the way to search, et cetera, right? I mean, you find a 6-year-old, they're going to type in the 3 words they care about and use Google, no problem, because it's the only thing they've ever known. But more and more so, older users who may have used the advanced search heavily at first have realized, no, I can just do this as well. So there is going to be I think, an evolution of how people use these generative AI platforms, these large language models, these prompts, as it were, right? But I think more so that's going to be an evolving, almost UI UX kind of paradigm over time, in terms of how prompts should be structured, how they should be authored, with all of the various LLMs that are out there. Obviously, ChatGPT and Bard, but then we have many kind of smaller, open source models, et cetera. They're all going to start following the same kind of approaches and standards, I would guess, naturally, just because there's less, pure laziness. There's less user training they have to do if they work like ChatGPT than if they try to do things out on their own, right? We're at that weird inflection point right now where nobody's quite sure how to use these, and there's not a UI or clear documentation. I think that will come, and then it will slowly kind of smooth out, is my guess, as people just get more intuitively able to use these.
I like to add a little bit to that. I think that's where these as this technology get better, and a lot of those contexts will probably be included in an automated fashion. Right? I think that the prompt, right? I mean, for example, like if I logged in, who I am. For example, like the question that you mentioned about getting, where do I get my pay stub, right? I mean, you are an employee. It knows where you work. It knows where. So all those contexts will probably be filled in, pre-filled in as part of the prompt. So you don't have to. You just kind of on the system, maybe as part of the system prompt, you will say, this is the employee. He lives in this city. Works in Germany. He speaks German. And he belongs to this department. So all those contexts are filled in as part of the prompt, and then and then you will then it comes to a question that I want to ask. Based on these background contacts, how do you answer this question that he asked? And he will know exactly which set of document to search, right? Because there's no need to search like English or US based kind of documents or things. It doesn't work there. It doesn't, it's not. So all those would be kind of, I would say, more or less automated. I mean, I think the reason these advanced search doesn't exist anymore is just because, I think a lot of those contexts can be easily kind of just infer, like to some extent. There's no need to be explicit about it. So.
Absolutely. And to Scott's other question, and kind of what are we doing with it? I tend to be pretty blunt, so I'll just kind of give the big background kind of for what I see here, right? So what I see globally at organizations right now is ChatGPT came out, board members saw it and said, wow, that's magic. That's got to be able to save us some money. They went to their CEO and they said, hey, figure out how we're using generative AI, right? And their CEO said, CTO, how are we doing this, right? And so I've seen a bunch of organizations that are currently in, I'll call it that scramble phase, to say, we've got something new and shiny and looking like it's powerful. How do we start making this functional and usable, right? We're a systems integrator consulting firm. And so naturally, we're working with companies on this kind of challenge. And generally what we've found, and we've seen kind of the approaches be, is first step is just workshops. How do we start talking with the users who are looking at this as a chance to be educated about what does the technology do? How does it work? Similar to what we're doing today, right? But second, how can I take a practitioner who's worked with this at all and use this to start breaking down our problems, our challenges, our use cases, and ideating where are some possible kind of potential indications, implementations, sort of things we can do, right? What we've generally found is that in organizations, at least with enough willingness to get people onto a workshop who are, not quiet, they're going to talk, they're going to give ideas. There are no lack of ideas within an organization for how to use this technology. Now, some of those are going to be wildly off base in terms of, it's completely out of line with the reality of what the technology can do, right? But many are actually going to be applied. And so, an example, we're working with one of the large insurance firms. In a 1 week of workshops, there were 55 different qualified ideas that came out of workshops with a group of about 20 people, where they think there are really kind of things that we can do here, right? The next thing that we typically do is we put these through the great filter of, how much work is it going to take, and is it economically viable? Right. The one thing I will say about generative AI that is not kind of, screamed from the rafters by OpenAI or Google or anybody else is it is still very expensive. There is a filter here to say, how much money are you going to save doing this? Or how much money are you going to make doing this to make it economically viable? Putting ChatGPT answers on your website for every query when you have 1 million queries a month is probably not the best use of money if, the majority of users aren't going to get a lot of benefit out of it. But for case deflection, if somebody's trying to open a case, or for your service agents behind the scenes, if I can reduce 4 minutes of call answering time in terms of, costing me maybe 50 cents a minute for a 10-cent query, that's a really good, economic trade-off. And so there is that great filter of, where are things economically viable to begin with, right? After that, we typically are going to come up with a short list of projects, and we're going to do POCs on those. And so many of those are using retrieval augmented generation in the enterprise space, not necessarily for pure search scenarios. I'll give an example. Doing a project with a well-known hedge fund right now, and as part of being a hedge fund, a regulated organization, they do lots of deal pitches, and they have to put disclaimer language on everything they do. Right. They spend lots of time generating disclaimers. And they have, highly paid, relatively new people who don't always get it right that are just generating disclaimer language for every proposal they make. And they make lots of proposals, many of which don't actually close. Their idea was, hey, can we use generative AI to generate disclaimer language? And so the approach that we're taking to that is, okay, can I go and get embeddings of all of the various disclaimers that you've had in the past, broken up by the individual disclaimer paragraph or chunks, right? Can I intelligently chunk this, load this into a vector database as well as a keyword database? When we have a new proposal, let's read the proposal, ask ChatGPT to summarize that into a few words and go do a search, right? And find the information out of it. And now let's ask, the large language model to generate some sample disclaimer language that's going to be applicable here, right? We don't anticipate this is going to be foolproof legal language to begin with. Lawyers are very, very good about using words in complex ways for multiple meanings. And I'm married to a lawyer. I'm not even going to begin to try to say I, as a human, could replicate what she does, right? But the short answer is what this can do, and what they're finding this can do, is get them, say, 75, 80% of the way to, these are the concepts we need to look at. And maybe we have a lawyer take a quick pass at it and adjust the language slightly, but we've at least found all of the major issues here that we need to have disclaimers on based on similar deals we've done in the past, right? Similar, concepts and language to the current deal, pulled all the appropriate paragraphs, and then we can spend some time essentially being exception processors for that disclaimer language rather than trying to generate it from context or from scratch, right? They had tried doing this with a database in the past, right? Can I just have a database of every type of disclaimer that I do? But the problem is this language is also muddy and merged, right? Because we're doing this product or this thing, it has to interact with that. Large language models are proving very interesting and very good at being able to kind of merge these concepts and make coherent thoughts and sentences about it, right? And right now, to be honest, we're doing this just with generic global large language models. At some point, there's going to be a legal large language model that's trained purely on contract data that folks have used, right? Companies are going to start doing this for themselves, and the huge Fortune 10, Fortune 50 organizations that have massive bases of all the contracts and negotiations they've ever done. That can help understand and express that language more accurately. But I still think you're going to have that retrieval augmented generation part of it that is looking and matching up that language, that we're not trying to apply global standards for contracts to specific areas that might have different verbiage, different approaches, et cetera. Right.
Hey,
So,
Eric, I love
the
the candor there. That's why you and I get along so well. So a couple things that spurred in my mind when you gave some of those examples is, helping people do the same things that they would normally do and having to apply some human intelligence to that, but getting past the mundane and making that process more efficient. So one of the things I'd love to hear, you and the others, if companies are either doing this or have thought about this, is, the things like the case deflection are going to be the more obvious ones to sell internally, but what about things like, using generative AI to improve product adoption, right? It's just the same, in my opinion, as if you have been using Adobe Photoshop for 20 years and I'm new to it. If I sit down with you and you watch what I do, you're going to take 20 years worth of manuals being read and mistakes made and corrections learned, and you're going to summarize the better way of doing it, right? Just like that generative AI solution could do. And so I'm really excited about things like that being in the product. I think Microsoft has already launched theirs. I believe Salesforce as well. And then secondarily, the thing that I've always loved about knowledge management, and I think this really turbocharges it, is, you know, getting to be a more proficient employee faster. So same kind of thing, right? If you've been at the company for 20 years and I'm just hired and you're my neighbor, right? You're going to just summarize so many things for me, ranging from that PTO example you mentioned, like, oh, you need to go around this, you know, challenge and go right to the fast track, to, you know, hey, I'm on a project and have, you know, you could give me better ideas on delivering that. So I'm curious what companies are looking at that, because it's not something I see highlighted on LinkedIn, right? People are showing these fairly trivial examples on LinkedIn of how they're able to, you know, write an email quicker or something like that. But to me, that's missing the power of these technologies. Kind of reminds me of when the internet first became commercialized and people just wanted to scan their brochure in and put it on a .com address, right? That's missing 80% of the value. So is anybody else willing to give examples of what your companies might be looking at? If not, Eric and Dr. Wu might be able to circle back to what they've seen.
I don't want to be the one hogging up the conversation, but we have a few use cases. I mean, I think a lot of it, indeed, I would say, you know, it does kind of prevent, I would say, like, avoid people have to start from a blank slate. You know, I think for coding and even like writing test cases and stuff like that. So we generated like kind of test cases for code and everything. So I think this is where I feel like an area that, you know, there will be a lot of, I would say, changes and disruption in the future, because right now, you know, the court basically says that whatever is generated by these generative AI, if there's no, like, I would say, any kind of human ingenuity, or I mean, they haven't been very specific about it. It's not copyright protected. You know, I think that the famous case is being that, like, you know, some people use, you know, Midjourney to create this comic book or something, a graphic journal, something like that, and then to try to copy that and copyright it, but then the court says, well, I mean, you didn't create any of these images, so you can't copyright these images. You could copyright all the prompts that you wrote to create those images, but you can't. And you could copyright the arrangement of all those images because you did that. But, you know, all the images are created by a generative AI, which you have no idea how it works, so you cannot copyright that. So I think it's similar things comes down, you know, to when you actually use it for doing something more technical, like writing code and stuff like that. So our approach has been, you know, if it's any code that's you know, a core IP, we just not going to use it. But if it's like, hey, test cases, I don't care if it's been stolen or not protected or anything. It's just test cases, you know, like, so those are fine, you know. So we use it for that. And yeah, and so certainly there's I mean, we're a software company, so obviously, you know, that helped us dramatically improve productivity. So yeah, and the knowledge KM kind of application is basically, you know, what I talked about before. It's just using this retrieval augmented generation for kind of, yeah, getting the right document, the right place in the document, you know, to deep link it, you know, so you could give references and you know, so, and it's tailored to your data. And I think there's maybe one concept I wanted to clarify a little bit. There's kind of two ways to work with, you know, these large language model. I think one is that you really kind of retrain it. Like I think you mentioned about a legal LLM or something, or medical LLM or financial LLM. So those are kind of, probably require you kind of retrain it with like massive kind of corpus of contracts or medical related document. It's very domain specific documents. And it's kind of, I would say, a little bit kind of the pros is that, you don't need to do any retrieval augmented generation, right? The model knows the document, so it knows already. The LM already knows the domain, right? So so you can just answer it directly without doing this retrieval augmented generation. But the problem is that you have to train it, right? And what if ChatGPT come up with a new version of GPT? That's like GPT-5 or GPT-6, and a couple years down the line, maybe this GPT-7 or 8, right? I mean, you have to retrain those models again because those models doesn't know anything about you. And training these large language models is actually very, very expensive. It's actually very cost prohibitive to train it, right? And that's the other way to kind of work with this LLM, large language model, is basically through this prompting. I just prompt it, right? LLM actually doesn't know anything about your product or your specifics of whatever contract or your domain or whatever, right? But you simply kind of you prompt the language model with the set of documents. Say, this is my question, but you are going to answer it with this set of documents. And what's coming up with that set of document is the search, right? So if the search actually comes up, give you a very relevant part of your corpus from your document, that's yours, right? And then this is searching those and surfacing those documents out. But you're going to tell ChatGPT, you're only going to answer this question, provided whatever context of the user asking that question, right? And answer it with this set of document that's surfaced by the search, right? And if your search didn't actually surface anything, you could just say don't answer it, right? Don't even give it to ChatGPT, so you can kind of avoid hallucination, So that's the advantage, of course, is that it's highly adaptive, right? If ChatGPT, OpenAI come up with a new version of a GPT, the base model, right? It's GPT-10, a few years down the line, then your code would still work, right? It's still kind of searching it doesn't need to know anything about your data. You just search it and then provide it as a prompt, right? But the problem is that, the downside of that is that there's a limited kind of context, right? Your prompt has a certain fixed size. You essentially, that's kind of think of it as your working memory of your language model. It has I think now it's like 8,000 tokens or something like that. It cannot, so you cannot read your entire document or entire knowledge base and have all those contexts, right? So that's why you need the search to surface the most relevant document, the relevant parts of a document, right? And then give it to your large language model as part of the prompt and tell it to answer using those. So that's kind of the two way that people can work with this large language model. And I think this second method is by far right now the most I would say popular, and mainly because I would say the training these, retraining, training it one time, if there's what's going to make this worth it is that there's some kind of transfer learning process in the future, that somehow you could transfer the learning that you train to a next version of GPT-6 or 7 later on without actually retraining it, with that massive, because when GPT-6 or 7 comes out, right, it's not going to be trained with that massive kind of corpus of contract, right? So I mean, how are you going to you have to retrain it again? So then that's, you have to do that every time that they come up with a new version. Then it's very, very expensive. It's actually not very practical. So.
Great stuff, guys. Anybody else interested in sharing what your organization is doing on these topics? Awesome. Maybe Eric, you could circle back to what Proficient has seen in those.
Yeah. So So what I can say at a high level is, so big picture, what we're seeing here with generative AI is that fundamentally there's two challenges, right? One is it's a net new technology that everybody's trying to understand, right? The second is everybody's trying to understand and find places that this is applicable. If we look historically at kind of where AI has provided a lot of value, essentially you're usually going to have I'll call it a front runner in the space, somebody who shows, hey, I can use AI to do this, and then a wave of people that catch up, right? And so I think we're in the stage right now, probably of identifying front runners in many scenarios, right? Because, creating the AI is hard, finding ways to use it is equally hard in many senses where it's actually going to be useful and applicable. Where I'm seeing this kind of apply in organizations, and to use a great quote about this space from Sam Altman, who's the founder of OpenAI, AI is not going to take people's jobs in the near term. People who are good with AI are going to take people's jobs in the near term, right? And I'm butchering that quote, paraphrasing it, let's call it, right? But the short answer is what we're seeing is that we're seeing a lot of folks in an organization have this in their daily life and start playing with it and start using it and start trying to say, hey, I've got this really painful task. How can I automate this? How can I make this easier, right? You're getting your internal entrepreneurs, as they are within companies, that are starting to try to figure out how to actually use this for their own use cases. Accordingly, there's I'll call it an organizational backlash to that, saying, hey, we saw what happened with Samsung. Don't upload your code into ChatGPT. All our data is going to be, made public with this. Or you're seeing the horror stories of the lawyer who submitted fake cases into the federal court of appeals in the U.S. right, and has been essentially dragged through the mud many times over. But essentially, what we're seeing is organizations grappling with that effect of people see how powerful this is, want to use it, but have to maintain some control over, how is it being used. Retrieval augmented generation has been a tool that we've used in that scenario, right? Because I can use it, but I don't need to send all my data externally. I can use my OpenAI model for my organization, right? That lives within my Azure tenant, or maybe my Google Bard models or Palm models that live within those tenants, right? But essentially where we're seeing it is that innovation is coming from ideation of not the AI experts in the company, but those that are actively having problems within their own daily life and saying, I want to make this better. A real simple example, and this is a stupid example just from me playing with this, right? We use Slack in our group. We had a bot that I had found online years ago called WhoBot, that its only purpose in our organization was allow someone to say somebody's name plus and give them fake virtual internet points for doing something good in the organization, right? This little, small reward mechanism had everybody kind of loving it. We had people with thousands of points, right? And it was running on a free Heroku instance. I wasn't going to pay for any of this. And then, Heroku decided no more free instances. The whole thing went away, and I was too lazy or busy, or I was actually having a kid at the time. And so I was not going to go and figure out how to make all this work. And so it went away. And for the next year, I was whined at incessantly for where are my points? Where did WhoBot go, et cetera. Right. So one night I'd been whined at one too many times. And so I went to ChatGPT and said, write me a Slack bot that will take these pluses and do this. And it was a little bit more, abstract than that. There was, doing it in stages, right? But got something working. I wrote no code, right? I am a programmer by trade, but I have not programmed in many years. I get to play in PowerPoint in conversations like this these days, right? But did it, had it working on my computer, and said, okay, now take this and modify it to work on Azure, right? And so it tells me, okay, we're gonna use this data structure instead and deploy it in that way. And with about 3 hours of work, we had a replacement to this WhoBot program that's now taking pluses and minuses and keeping track of scores essentially for free within our Slack instance, right? That's an instance of just one person having a problem or an annoyance, which is everybody bugging me that it's gone, right? And saying, I'm going to spend a little bit of time to try to do this, and we can get outcomes from it. Now, there are people all across organizations that end up wanting to do that. And what we've found inside our company is the people most likely to do that are college hires. College hires who have never known any of the constraints of the workplace and get here and say, man, these timesheets are terrible. And so they find some way to use ChatGPT to generate a timesheet by giving a description of what they've done. And well, now they can copy paste into a system, right? Or, they have to do reviews and well, hey, I just want to write 3 paragraphs and I can give a nice prompt that's going to generate more of this structured review format that people are going to do, right? And so what we've tried to do internally is empower discussions and empower forums for people to share their ideas for what they are doing internally, right? We have to have restrictions around this pretty significantly around do not upload client data into ChatGPT or do these sorts of things, right? There's clearly downsides and pitfalls to this, but we've found internally that by simply enabling resources to share their findings publicly, we're now having growth via the masses rather than growth by a few folks who know this really well saying this is where it has to be used, because I think we're still in that discovery phase of where is this going to be most applicable for an organization. I'd be curious if other organizations here are doing that same thing, because the people who know your problems that can be solved by this best are the people who have the problems. And so in many ways, I think a groundswell is going to be needed for at least a little bit of these initial ideas. And you will get the Microsofts and the Salesforces and the Googles coming in with specific use cases that are going to be more broad. But that's kind of broad range challenges that are being solved rather than specific challenges that are being solved in many scenarios.
Does
that make sense?
Excellent, Eric. And actually, Monique had a great question in the chat around planning for, resources and skill sets for the training, the programming, the maintaining of those Gen AI implementations. I'm curious if you can give some perspective there.
Yeah, so depending what it's learning from, there are multiple skill sets I think that are important. Knowledge management is going to be one, particularly, these models are as good as the data they're being fed and they're learning from. We've seen various cases where, users' documents, they're clear to users, they're not so clear to generative AI. Maybe I have 3 things named the same thing and a user can understand, oh, that's for this platform or that platform or this platform, right? But you've got to be able to actually differentiate those maybe a little bit better for a generative AI model to understand them appropriately. And so there's going to be just some knowledge management, taxonomy, ontology, information architecture kind of capabilities that are going to be needed to make this kind of truly valuable from a knowledge perspective within organizations. The other side is going to be on the data side. Things like data governance become hugely important because we have to be able to understand where answers are coming from, be able to trace the lineage of data potentially in certain more regulated organizations or industries, right? And those are going to end up starting to become very applicable. The third, and this is honestly just this is as much as anything else a broad concept as opposed to specific pieces, right? You have to have a employee base and knowledge base that has a continual thirst for learning and are willing to put time in to try to figure this out on their own, at least up front. I'm sure in the future we're going to start seeing degrees or certifications that, I'm generative AI certified, or I'm an AI engineer degree, right? That's going to start coming out of universities soon, but we're not there yet. And so fundamentally, where I've found that we need to do this right now, at least internally with our organization and at some customers, is there needs to be an organization reinforcing that it's okay to try things and learn and to break things under constraints, not break things in terms of giveaway data or any of the real scary things of this, right? But to try an experiment that isn't going to work, right? And let people have that freedom to try it, right? And have people that are going out and they're looking on everything from Twitter, X, whatever the heck it's called now, to YouTube, right? Videos on what's going on, and pick up the knowledge they're seeing others talk about and try it internally, right? This is we're at an entrepreneur's setting for generative AI in companies at a moment. And so people need to act like entrepreneurs if you're really going to start getting benefits out of this, is my personal viewpoint.
Yeah, absolutely agree. Well, hey, we're getting close to the bottom of the hour where we had anticipated ending. So I just want to be respectful of everybody's time here. But Eric, Dr. Wu, Nick, and everybody else, very appreciative. I always learn a ton from these sessions, and that's exactly why I started this little project, and it's very exciting to continue on. So if anybody wants to shoot me an email with any questions you weren't able to ask or anything like that, I can always help facilitate post conversation. But otherwise, I'll just leave you all with best wishes for having a great day, and I'll send out the recording shortly.
Thank you.
Thank you.
Thanks,
Bye-bye.
everybody. This was
Yeah,
great.
thank you, everyone.
Good one.